Hey ladies and gentlemen, welcome back to section 4.8 quadratic inequalities, jumping right into number 7 where we are asked to solve this inequality algebraically. Well, now I first showed you in the other video how to solve them by factoring. Well, now I'm going to show you to solve through the quadratic formula. So let's go ahead and try it. Remember, anytime we try to solve anything, this needs to be 0 over here. So I'm going to subtract that 27 over to get 5x squared minus 27x plus 10 is greater than or equal to 0. Now I'm going to use the quadratic formula that I stated earlier, and here it is right over here in case you didn't remember. And also our a is 5, our b is a negative 27, and our c is 10, putting them all in here. So I need opposite b, which is going to be 27, plus minus the square root of, close it off, then it's going to be negative 27, that's squared, minus 4 times 5 times 10, which is our a and c. That's going to go all over 2 times our a, which is 5. Cleaning things up as I'm going to work across, it's going to be 27 plus minus the square root of 729, as that is the negative 27 squared is a positive 729, minus 200. That's going to go over 10. So I'm going to clean it up one more time. It's going to equal 27 plus or minus the square root of 529. And that all goes over 10. All that it was is the quadratic formula. We can keep going with this though, because the square root of 529 turns into 23. So it's 27 plus minus 23 all over 10. Now I'm going to separate those two guys. It's going to be 27 plus 23 over 10. And it's going to be, let's go right here, where it's 27 minus 23 over 10. This guy will give you a 4 over 10, simplifying to 2/5. Then for the blue guy, we have adding up to 60 on top over 10 on the bottom, which gives us 6. So our two answers are going to be 6 and 2/5, right? So we can put those on the number line right away. So I'm going to go with 6 and 2/5. But now please remember, and hopefully we can remember back, remember when we had solutions and how to go back to factors? We had to go x equals 6, right? And then x equals 2/5. How do we go about this? We went x minus 6 in one, and then we had x minus 2/5 in the other. Here we had to multiply by 5 to get the 5 off the bottom, so we had 5x minus 2 and x minus 6. These guys, right, make up this, should multiply to this. So would you say that this has to be greater than or equal to 0? I'm going to say that one more time. This multiplies to that. So that was greater than or equal to 0, so this should be greater than or equal to 0. We have both of our solutions. So you did the hard part. Now we just have to do what we did on the past two examples. So I'm going to pick numbers that are smaller than 2/5, plug them in for both of these, see if they give me a positive or a negative. So I'm going to pick 0, plug it in. 0 minus 6 is a negative. Remember, I do not care about numbers. I care about positive and negatives. I plug 0 in here. That's 0 minus 2, which is still negative. That gives me a positive. Positive is greater than 0, so that's what I'm looking for. Here, I'm going to pick 3 right in the middle. 3 minus 6, that's going to give me a negative. 3 times 5 is 15 minus 2. That gives me a positive. This also gives me a negative. That's not what I'm looking for. And then I'm going to pick any number bigger than 6. Let's try 7. 7 minus 6 is going to be positive. 7 times 5 is 35 minus 2. That's also positive. So positive times a positive gives me a positive. So that works. So I'm looking at these sections right here. So let's see if we can write ourselves an inequality. Here we have 2/5, and I'm going to say x is what? Less than. What kind of inequality should we have? Less than or equal to 2/5. This is an or statement with them going away, or x is now greater than or equal to, because of the inequality, 6. And then this would be your final answer for your inequalities. All right, this is all stuff that we've seen before. It's just a lot coming at you right now, a lot of new material that we're working with. But that closes up section 4.8 and chapter 4 with quadratic inequalities. Good day.